Bismillahirrahmanirrahim. Now we have to discuss circular measures. And in circular measures, it is up to some extent related to the topic mensuration, which you have done in O-level mathematics. But here we have to use the angle in terms of radians. That is the difference. Otherwise, strategy of solving the questions is similar to mensurations. So let's start it. Okay, these are circular measures. We have mainly to cover these areas: length of arc, area of sector, and area of segment. Before discussing these things, let's discuss what do we mean by these terms, few other terms. You know, if this is the center of circle here, it is almost at this point, then taking any 2 points on the circumference, like this point, and another point let's take here, then the straight line between these 2 points is, if we draw a straight line joining these 2 points, so this line, this straight line, what is that called? That is called chord. And this curved path between these 2 lines, this curved path, this one, that is called arc. Now there are 2 arcs between these 2 points. One, let's mark another point here. Let's say this is C and this is another point D. Then if we move on this circumference via D towards B, it is possible that we can come to B from this path. So that is the longer path if we move this way, passing through D and coming to B. So this is also an arc. So what is the difference? How we can differentiate between these 2 arcs? So A, C, B. If C is in the middle, that is A towards B from passing through C, then it is called minor arc. This is minor arc. And if we move from A through D towards B, that is called major arc. This is minor arc. We can say that this is minor arc. And from this side, this is major arc. This arc, this one, this is known as major arc. So you can say that the arc on the side where the center of the circle is there, that arc is major arc, and the other one where center of the circle is not there, that is minor arc. And AB is a common chord between them. So these are 2 things. Now the next one we consider here, that if we draw these lines again from one point to the center, one line, and another line from the center to the circumference at any other point. Then this area, if we consider this whole area between the two radius, this is one radius, this is another radius, then this area is called sector. Once again, A, B. Again, we can say that the circle is divided into two sectors. One is larger than the other, and we mark other area this way with blue lines. Then this area is another sector. What is the difference between these two? This is called minor sector, then this is major sector. That means if this angle theta is less than 180, that sector will be minor sector, and on the other side there will be a reflex angle. So wherever there is a reflex angle, that is major sector. And we have to discuss one more thing before discussing their formula. There is once again, if we mark 2 points like this is 1 point, and this way, then area between the chord and arc, this area between the chord and arc, that is called segment. This is segment. Once again, there is another segment. So the other segment, this one, this is other segment. So we can say that this is major segment, and this is now minor segment. And one more thing what we have to discuss before starting the topic, there is okay, let's discuss the length of arc and area of sector, then we come to segment, and then I will tell you another thing. So here, length of arc. If we have to find this length of arc, then angle at the center is, if we mark this angle this way, and another angle, other line this way, and the angle at the center, this angle is theta. So as we have already discussed that 180 degrees is pi radians and 360 degrees equal to 2 pi radians. Keeping this in mind, formula for length of arc Actually, you can say that this is once again that is a ratio. Ratio, like what? That angle and length of arc. Length of arc. You can say that circumference, this whole length of a circle, that is also an arc, complete arc, when angle is 360 degrees. And when angle is 360 degrees, length of arc is 2 pi r. R is radius of circle. Okay, when angle is theta, what should be the length of arc? Let's denote length of arc by S. Then applying simple ratio, we multiply this way, cross multiplication. Then this is 360 into S equal to theta into 2 pi r. Then length of arc is theta over 360 degrees. So far the angle theta is in degrees into 2 pi r. Now if we change this angle 360 degrees, 360 degrees, that is equal to 2 pi. If we change both the angles in radians, now theta is in radians. If it is in radians, now we won't use this symbol of degree. And on the other side, angle 360 degrees is equal to 2 pi in terms of radians. 2 pi radius, these 2 pi is cancelled. Then length of arc is r theta. This is length of arc, you can say. So this way we can prove that here. Be careful that theta is in radians now. If you use this formula, then theta is actually in radians. Okay, second, we have discussed here, that is area of sector, this one. Now if this is angle theta, then once again ratio of angle and area. If angle is 360 degrees, area is pi r square. If angle is theta degrees, area is, let's say, A. Then once again cross multiplication, there is direct proportion between angle and area within 360 degrees. Then area is theta into pi r square divided by 360. 360 will be divided on this side. Once again, if we change the value of angle to radians, 2 pi, this will be pi r square. Now pi is cancelled. Then area is equal to half r square theta. Then this is the formula of area of a sector. This is area of sector. Now here area of sector is half r square theta. Can we say that r square theta means r into r theta? That is same r square theta. Then r theta, we have proved right now that r theta is length of arc, S is length of arc. Then An alternative form of this formula we can write as half RS. This is another form of the same formula, area of sector. So now you can say that area of sector can be represented in two different forms. So area of sector is half r square theta or half rs. That means if the value of length of arc is given, then simply half rs we can apply this formula to find area of sector. Okay, now another thing, this you have done in O levels, area of a triangle. Area of a triangle you have done, then I will relate it to the area of segment, area of triangle. If this is a triangle and the sides of this triangle are A, B and C, these sides are A, B and C, then area of triangle, you know, that is half AB sine C. That when you have sides A and B, sides are A and B, then angle will be included between these two sides. If you consider the sides B and C, then sine of angle A will be taken. Now it will be half BC, then it will be sine of A. And if it is AC, half AC, then sine of B. That means whenever you have two sides, then sine of included angle will be considered in order to find area of triangle. Now if there is an isosceles triangle, like if there is a triangle this way and this angle is given theta, this length is A, this is also A if this is isosceles, then area of this triangle, what will it be? Half AB sine C, but now there are, both of them are A, so it will be A square sine theta, using the same rule what we have applied here. So its area will be half A square sine theta. Okay, now keeping in mind this rule, we will apply it on the area of segment. How we can apply this? Now if we have to find area of this segment, then if we join these points to the center of circle from here till this point, and we have to find area of this segment, then we can say that area of segment, what is it? This is actually area of this whole sector. If this angle here, that is theta, then area of sector minus area of triangle minus area of triangle. Now, as we have derived the formula for area of sector, half r square theta minus area of this triangle. You know, this is radius, this is another radius. So two sides and included angle. Then its area will be half r square sine theta. Same rule that whenever there are two sides, so half AB sine C. That is the rule we have applied here. So we can write it in more simplified form. Half r square is common, theta minus sine theta. Everywhere in all these formulas, theta is in radians. Theta is in radians in every formula now. So if theta is in degrees, first of all you have to convert it to radians. How will you convert it to radians? By applying that ratio pi is to 180 and radian is to degrees. So that way you can find the angles. So these are three formula. I rewrite them once again. That number one, what we have concluded now. Number one, length of arc. Its formula is S is equal to r theta. Number two, that is area of sector. We have denoted it by A. A is equal to half r square theta. And the third formula what we have derived now, area of segment. Area of segment is half r square theta minus sine theta, and in all these three formula the value of angle is in radians. Theta in radians. That's what you have to keep in mind, that theta is in radians. Theta in radians. I have highlighted it, that you have to keep in mind. Okay. Discussing the formula of circular measures, that appears to be very simple. ऐसा लगता है कि ये तो बहुत आसान है, but attempting questions to apply these formula, that is slightly challenging. So that's what you have to keep in mind, that you have to plan before attempting the question. In another video, inshallah, I will solve few of the questions from past papers in order to have an idea that what strategy we should apply so that we can use these formulas and solve the questions easily. So for the next time, Allah Hafiz.